Okay, so in the first lecture, I will give you introduction to time series analysis, introduction to time series data, tools for examining time series, as well as on how to measure forecast accuracy and measure forecasting accuracy. Okay, for first, what is time series data? So time series data is a sequence of observation taken over time, usually equally spaced. So we use a symbol to denote a time series data. For example, we use YT. So YT with T equal to 1, 2, 3, and so on up to N. So N is sample size. So we use, for example, here YN is used to represent or to denote the first observe values, the first observation, and then Y2 for the second one, Y3 for the third one, and so on. So in terms of time interval, time series data could be yearly, could be an annual data, monthly, quarterly, weekly, daily, hourly, and so on. So although time is continuous, but time series data are usually reported or collected at discrete point in time. For example, we collect time series data once every day. For example, so we collect one value for each day if we have daily data, or we collect one value for every week, okay, or every month you have monthly data, or you have quarterly data, you collect data one for each of quarter. So although the time is continuous, but the time series data normally we present it as a discrete data. So it is usually reported or collected at discrete points in times. So this is an example of time series data. So this is what we call that international airline travel data. Okay, it's a log transform values. Okay, in terms of the distance, so log miles. So this is monthly data, example of monthly data. So the two main features of this series, you can see that the values of the series keep increasing. That is what we call as trend. So we see that it has an upward trend because the values is keep increasing. So that's what we call as trend. And then you can see the certain month it has smaller, lower values compared or relative to other months. For example, this one certain months you can see, and it is happen what we call it in the same month. For example, here maybe October, also every October, or every other months. You can see the lower, it has low values compared to other months, and then certain month also has higher value as compared to other months. So when the data for that values increase, and then what we call that decrease when what we call that I mean for the certain same months. So that what we call as seasonality. So that's what we call seasonality, seasonal variation. So there are a number of objectives of time analysis. So here we have two main objectives in this course. The first objective to what we call as compact description of data. So we would like to use time series analysis technique to describe, to help us to describe time series data. Okay, so for example, using classical decomposition, we would like to describe the underlying time series pattern of data, because we know that. So I mean, as given here, the general mathematical representation of the decomposition approach is given by this. So YT is the observed values. So you refer to the example that we considered just now. So this is YT. YT. What we see here is YT, the observed value YT. And then YT is function of the underlying time series pattern, the trend, seasonal, as well as the irregular or random. So YT, the observed values, is a function of three underlying time series pattern: the trend, seasonal, as well as the irregular component. So in this case, YT is the time series value, the actual value or the observed value, the values that we can see, the data that we have, the one that we can see or we can produce, we can what we call that what we call immediately produced plot. This one YT, the observed value, and then TT is the trend cycle component. So the trend cycle component is a component of the series that represent the long term direction, of the series. But there is slight difference between trend and cycle. But what we call for certain model, we can just simply treat the two component as the same or the combined component. Trend cycle component, for example, classical decomposition technique that we're going to discuss later on in the following lecture. We simply we treat the two component trend cycle as a combined component. So again, trend cycle component is a component representing the long-term direction of the series. So in the next slide, explain what the difference between trend and cycle. And then ST is the seasonal component, and ET is the regular, remainder, or random. Okay, random component. So meaning that YT is made up of a different component, T, trend, seasonal, and then irregular component. Okay, just what I mentioned just now, the trend component is a long-term pattern or direction, whether it is an upward trend or downward trend. So in a time series data. So again, trend component is a long-term pattern or direction. So it represents the long-term direction of the series. A trend cycle is a wave-like pattern about a long-term trend. So that's like what we call a difference between. So the trend normally it represents the upward or downward trend. Okay, cycle is a wave-like pattern about a long-term trend. So if you look at to the example given in the following slide. So this is what we call an example of the trend, upward trend. So in the long term, it represents the long-term direction. So keep increasing. Then another example, this one. So this is an example of a cycle. Okay, you can see that values decrease, increase, decrease. It has a cycle. So long-term direction, but it's not consistently increasing or consistently decreasing. So so this is what we call a cycle. So seasonal component is a sawtooth pattern that repeats itself in systematic interval over time, just like before. Example that we considered before, you can see that certain month it has the values what we call that decrease. Certain month the value increase compared to or relative to other months. So that's what we call as seasonal. So seasonal component is a sawtooth pattern that repeats itself in systematic interval over time. So what we call that it happens. In the same month. Okay, so if you have monthly data, if you have quarterly data, then I mean the lowest value or the highest value also happen in the same quarter every year. So random, the third component is random or irregular component is the component that accounts for everything not covered by any of the other components. Okay, the three components before trend, cycle, and seasonal. So random variation cannot be predicted. So basically, using the time series technique, for example, just like I mentioned before, the classical decomposition, through the classical decomposition allow us to decompose this observed series into the three subcomponents. For example, this one, so the data you can see that this is the observed YT, this is the YT. Okay, and then we using classical decomposition. This one use additive. So later on we will discuss there are two methods that we're going to use, the additive as well as multiplicative decomposition. So this one example of additive decomposition, you can see that this is the observed value of YT. Okay, the data that we have, the data that we can see. Okay, and then we can use the decomposition techniques to decompose the YT into the three subcomponents, trend, seasonal, and a random component, so that we are able to see or we are able to understand better in terms of the long-term direction of the series, the trend, long-term direction, as well as the seasonal variation. So which month it makes the series to be higher. So at which month it makes the series to be lower relative to other months. If you have monthly data, so you can see that this is the estimated seasonal variation or seasonal effect. So for the trend, you can predict after you decompose, then you can use this information to make prediction. Okay, for example, if you have this kind of trend, and we know that the future is going to be, our best, what we call that prediction. we can see we can based on this we can say that it's going to be increased. The trend, the future trend is going to be higher than the last one. So we can make prediction. Okay, this one also we can, after you compute, you estimate the seasonal effect, the seasonal variation, and then you can use this. You can use the value as your prediction of the seasonal variation for the future. Okay, but the third component, random, it is something random. It is random. The value is random. So we cannot use this value to make a prediction for the future irregular component. So this one, trend, seasonal, we can predict. Okay, but the random variation cannot be predicted. Although we can using data, we can compute. We can estimate, but we cannot predict the future value of the irregular component. So this example for the case of identity decomposition. So this one we will discuss how to perform or to calculate decomposition in the following lecture. Okay, and then this is another example. So just like I mentioned before, for this one is what we call that trend, upward trend, but this one is cyclical. But again, we treat the two component as the combined component, trend cycle component. So after we analyze data, then we can use the information to produce forecast. So that's another objective. The analytic of time series data, we would like to produce forecast. We use that for forecasting. So by evaluating underlying characteristic of the series, we are able to say something or predict the future values of the series. Okay, so a view of forecasting. So in order to produce good forecast, it depends on number of things. So forecasting situation vary widely in their first time horizon. How far we would like to produce forecast at the time horizon? How far we want to produce forecast, whether it is short-term forecast or long-term forecast. It depends on the what we call the data. Certain data has a strong historical pattern in terms of the trend, seasonal, and then you can easily produce forecast, a good forecast not only for the short-term forecast, but also for long-term forecast. You have monthly data, then you can use forecast for many years ahead. Okay, but certain data, I mean, we are not able to produce good forecast for long-term forecast. We are only able to produce for a good forecast for short-term forecast. Okay, if we just, for example, if we just produce forecast based on information that we have in terms of the underlying time series pattern, the trend, the previous, the historical pattern of the series, the trend, seasonal, and so on. And then factors determining actual outcome. Okay, certain data, time series data, what we call the movement of the series depends on other factors. It's not only depends on the systematic pattern, just like, I mean, systematic pattern. Just now I mentioned that the previous the historical pattern, the trend and seasonal pattern. Okay, certain data you just need to know or to understand the historical time pattern of the series in order to produce good forecast. But certain data, it requires you to know the other factors, factors determining the movement of the series, because it's not only depends on the previous historical pattern of the same series. And then types of data pattern. Okay, so whether it has seasonal, whether it has trend. Okay, so so meaning like you need to take into account that one in order to determine a good model that can help us to produce good forecast, and then many other aspects. So we will examine 4 variables for which forecast may be required. Okay, just consider a number of examples here. The first one, the monthly Australian electricity production from March 1956 to August 1995. So you can see the season, it has a strong historical pattern, a trend, and then seasonal variation. So observe there's an increasing trend and then increasing variation each year. Okay, the size of the size of magnitude of variation increasing, and then strong seasonal pattern that is slowing changing in shape. You can see that I mean the effect of seasonal variation, the magnitude keep increasing. So the strong historical pattern made this variable an easy one to forecast, because it has previously, you can see that it has systematic trend. The trend increase, and then also has seasonal variation, so that you can use that information to produce forecast for the future values, forecast of the future values of the same for the same series. Okay, so in this case, it is sufficient to rely on the information on the past historical pattern of the series in order to produce good forecast of the same series. And then because of the changing seasonal pattern, some of the early data may not be useful in constructing a model, especially for additive model, but certain what we call that techniques allow us to have this kind of changing pattern in seasonal variation. For example, the multiplicative decomposition, that one we will discuss later. So forecasts are important for this data. You have this kind of data, okay. So forecasts are important for future planning of electricity production facilities and ensuring existing facilities can meet peak demand. So that's what we call the objective, the reason why we need to produce forecast. We need to produce forecast for certain times data. Okay, for this data, it's not that difficult to produce good forecast. We can just it's sufficient to only use historical pattern in order to project the future value of the series. And now consider another example. So Treasury bill contract on the Chicago market for 100 successive days. So this is the daily data. So observe the downward trend. Okay, so the values keep decreasing. It may only be a short downward movement in the middle of a highly variable or volatile series of observation. So that you also need to into account. So for example, you have, so normally this is what we call a typical pattern of the what we call that the share price, for example. So in this case, you can see that I mean this kind of series is quite volatile, so it's not really. So in this case, the question is whether the downward trend is likely to continue. So in this case, normally you have this kind of data. It is if you just use the historical pattern of the series to make forecast, then we are only able to produce good forecast for the short-term forecast, only for the next few points of view observation, not for the long-term forecast. Okay, so for this kind of data, if you want to produce good long-term forecast, then I mean, we need to have more information. So not only the past historical pattern, we need to know what we call the other factors that determines or other factors that influencing the movement of the series. And then the third example, sale of product C from a major oil company. So product is a lubricant sold only in units of larger volumes. So to forecast such a variable, necessary to investigate the nature of the product, who is buying it, and what is their future needs are likely to be, because this one is totally what we call that it does not depend on the previous values I mean at all. So you can see so the values of this is really is highly depending on other factors. So you need to know the factors that determines the what we call it, the movement of the series. So this one you cannot produce forecast by simply using the past values of the series, the information on the past values of the series. So the next example, Australian monthly clay brick production from March 1956 to September 1994. So observe that the market is seasonal and quite volatile. So it has seasonal variation. Okay, the first half of the series, it has a systematic pattern of the series, trend, seasonal. Okay, so but at the second half of the series, it starts to behave differently. Okay, so accurate forecasts are very difficult unless the cause of the fluctuation can be identified. So again, this one. So perhaps for this one, you can use combination of the past historical pattern as well as other factors, like other variable, explanatory variable to explain what we call the behavior of the series. So in order to produce or to determine a good model, then you need to understand the series first and then determine whether I mean what you need to include or to take into account in the model that you want to construct, so that you can use the model to produce good forecast. Okay, and also you need to, based on the graph, based on the series, also the characteristic of the series, by understanding the behavior of the series, it allows to know whether we are able to produce good forecast for long term or only for the short term forecast. All right, so tool for examining time series. So there are a number of different tools, the graphical summaries and numerical summaries, but you need to know the difference between time series and cross-sectional data, because different tools is suitable or appropriate to be used for different types of data. So the time series data, just like I mentioned before, is a sequence of observation over time. So for example, monthly sales figures, daily stock prices, weekly interest rate, annual profits. So in forecasting, we try to estimate how the sequence will continue into the future. So this is what we call univariate analysis. We just make forecast, we produce forecast only based on the previous previous values of the same series only. So we just need to have the single values of the series in order to produce forecast and forecast of the future values of the series. So that one we call as univariate analysis. We just analyze one series, and then based on the past historical pattern of the series, then we produce a forecast for the future value. So that one we call as univariate analysis. And then another type of data we call as cross-sectional data. This one normally we use for econometric data, econometric model. So cross-sectional data, all observations are at the same time, are given at the same time, or are collected at the same time. Okay. So for example, this one, so if let's say you collect data of weight of a 1%, so annual weight for 1% for 20 years. That's what we call as time series data. Okay, time series data. But if let's say you collect data of weight of 20 different individuals for any particular year, let's say for 2021, you collect data of weight for 20 individuals, and then that what we call as cross-sectional data. So observations are at the same time, are collected or are given at the same time. Times we collect over a period of time. So for cross-sectional data, we may wish to forecast the response, the dependent variable, using one or more of the explanatory variable or independent variable. Okay, just like what we did. I mean, for those that already learned with applied econometry, that you know what is dependent variable, what's independent variable. So dependent variable, it depends on the other explanatory variable that explain the value of the dependent or response variable. So we can use the same methodology, for example, regression, to evaluate relationship between multiple time series variables, multivariate analysis. This one we call multivariate analysis, or bivariate or multivariate. So univariate, only one single series. Let's say you have two time series data, different series of time series data, and you want to use one series to explain another time series data. That one we call as bivariate analysis. But you have more than two series, okay, and then you want to use the two series to explain one of the series. For example, using regression or econometric model, and then the one we call as multivariate analysis. Okay, the graphical summaries. So we have time plot, seasonal plot, and scatter plot. Okay, so there are other techniques of graphical summary that we can use, but this one in this course we just what we call that. I mean, in this lecture I introduced these three graphical technique that we can use to analyze time series data. So when first exploring data, visualize data through graph is always useful, okay, to inspect data first using graph, okay, by producing graph of the series. It helps us to understand the behavior of data so that we can make a better judgment, okay, in order to know what is the best model that we should use, okay, to construct, to feed the data and then to produce forecast. So basic feature of data including patterns and unusual observation are mostly seen through graph. Okay, so basic feature of data including patterns and unusual observation are mostly seen through graph. After you produce graph, you can see the pattern. So graph sometimes also suggests possible explanation for some of the variation in the data. For example, industrial dispute will affect time series production. Okay, you go back to the example that we considered before, this one, production of the clay brick production. You can see that after the first half of the series, then so instead of continue to increase the values, and then what we call that it drops, and then it has what we call a cyclical pattern. So why it behave like this? So if you produce graph, then you inspect the graph, then you have this kind of pattern, you need to investigate. So it's, what we call that. You produce graph and then you investigate and you understand why it behave like this. So for example, another example is changes in government will affect economic times pattern. Okay, so this one normally you can see this kind of situation. So on the what we call the share price. So when the government change, then the stock price drop, for example. Okay, so instead of directly produce a model, okay, to feed the data, it is important for you to understand data first, using graph, produce graph, inspect data so that you understand better, and then make a better decision on how the best model should be constructed. So where possible, this event should be adjusted for or included in the eventual model. The type of data will determine which type of graph is most appropriate. So whether it is time series data or cross-sectional data, or other what we call the types of data. So the first technique is time plot. The first graphical tools, okay, is the time plot. You can use time plot to inspect the data. So a time plot reveals any trend over time, regular seasonal behavior, and other systematic features of the data. So the time plot, you simply produce a plot against time. So let's say we have data, and then you just plot the values of the series against time. You have monthly data like this lah. Okay, this is what we call time plot. Time plot. So this component need to be identified and incorporated into the statistical model. So you produce a time plot, and then you inspect whether it has trend, whether it has seasonal variation, or other what we call that systematic features of data, so that you can include this. Okay, based on the graph, you decide whether each of these present or not, and then if present, then you need to include this what we call that each of these in the not necessarily all, okay, but only trend. If let's say only trend but not seasonal, then you just include trend, no need to include the seasonal. For example, regression later on we discuss. We use seasonal dummy to represent seasonal variation, and then we use a time trend variable to represent the trend. So you need to decide. You need to inspect the graph, and then you decide whether you should include a component of model that can represent any of these. So for this data, for example, so observe. So this one, the beer production. Okay, so observe the range of data, whether we have long enough sufficient data to have what we call that the reliable conclusion, okay, regarding the systematic pattern, and then the time at which, also observe the time at which the peak occur. So which month has higher values compared to other months, which month has lowest values compared to other months. So relative size of the peak compared with the rest of relative size of the peaks compared with the rest of the data. So this one peak and then lowest. And then randomness in the series, since data pattern is not perfect, randomness means that the different behavior, different variation of the series for certain parts of the series. So an important step in selecting appropriate and appropriate forecasting method or model is to consider the types of data patterns, whether it has horizontal, seasonal, cyclical, and trend. So horizontal pattern, if the series is just horizontal, okay, there is no upward or downward trend. So as this horizontal pattern exists when the data values fluctuate around a constant mean, what we call a stationary in the mean. For example, a product whose sales do not increase or decrease over time, over a period of time. And then seasonal pattern exists when a series is influenced by seasonal factors. So quarterly or months in a year, day of the week, for example, household electricity consumption in a country that has different seasons throughout the year. So normally during summer, the what we call that the consumption higher compared to other seasons. Okay, and then cyclical pattern and then trend pattern. This one I explained before. Okay, so a cyclical pattern exists when data exhibit rises and falls that are not of a fixed period. For economic series, the rises and falls are usually due to economic fluctuations, such as those associated with business cycle. For example, sales of products such as car, buildings, product, major appliances. So, so the sales, certain, for example, you have monthly data, then certain month it has high value and then decrease. Certain period it decrease, not necessarily months. So, I mean, it has what we call a certain period. It has increase and then after certain period and then it decrease and so on. It's cyclical. It shows a cyclical pattern. The trend pattern exists when there is a long-term increase or decrease in data. Okay, so for example, sales of other product, I mean certain product that consistently increasing or consistently or continuously decreasing. So many data series include combination of pattern. The Australian clay production series exhibits trend, seasonal, and cyclical behavior. For example, this one you can see that has combination of different trend time series pattern. The trend, cyclical, and then seasonal version as well. Okay, so the next graphical tools that we can use is quite similar to time plot. Okay, so seasonal plot for time series that are seasonal, it is useful to also produce a seasonal plot. The graph consists of data plotted against individual season in which raw data were observed. So a seasonal plot enables the annealing pattern to be seen more clearly and allows any substantial departures from the seasonal pattern to be easily identified. So you can see this quite similar to time plot, but this one we produce time plot for different years. Let's say you have monthly data, so you produce time plot separately for individual for each of the year, and then you put the graph overlapping each other like this. So this is what we call a seasonal plot. Okay, so again, almost similar to time plot, but the time plot we just produce plot of the series against time. Okay, so that we have different, our x-axis, we have different months for different years. Okay, but for the seasonal plot, we just have data for, I mean, if you have monthly data, January to December only, but then we have different separate time plots, the separate time plot for different years. So we put them together. Okay, this is what we call a seasonal plot. So this one time plot, a seasonal plot for the same series that we considered before, the Australian beer production. So note that production peaks in November and December in preparation for the Southern Hemisphere summer. So you can see this one. Okay. So summer normally what we call that the temperature, what we call that hot weather. So hot weather, so it encourage the consumption of beer. Okay. So, but it is least in winter. Winter, you can see, around. Okay. Okay, so winter around June to August, this one. Okay, so you can see that during winter, then the consumption, beer consumption, not as high as when during summer, because summer, as mentioned just now, high where the hot temperature encourage people to drink more. So there is, so again, this one based on the graph, you inspect the graph, you can see, and then you investigate why. So you can see, and then you understand. So here it has higher values compared to this one because this is during summer. Okay, people we drink more during summer, and then as compared to the winter. So there is 1 year in which the October beer production was higher than the pattern evidence in the other years. You can see this one. For one of the year, the value is higher as compared to the other three years, 3 other years. So 3 other values for the other 3 years. So this is what we call randomness. Just like the one that I mentioned before, randomness. It behaves differently as compared to the what we call the overall the average pattern. So again, if you are able to it would be good if we can investigate why for this year it behave differently. Okay, so that we can take into account that one as well in our model. And then the third graphical tool is scatter plots. So if we wish to evaluate a relationship between two times variables, so it is appropriate to investigate uh, it using scatter plot. However, we need to be careful for the spurious relationship caused by trend and not by actual relationship between variables. So if you produce scatter plot for times data, so you need to be careful for this one, because if let's say you have two times times this data for two different things, okay, for two different things. For example, you have uh, data, the price, okay, the annual price of a book, for example, and then you have another series, annual price of a car, a type of what we call a brand or a type of car. So the two things are not related at all, but because of inflation, because of the trend. Okay, so inflation, normally the trend of inflation keep increasing. The values, the price of the items keep increasing every year. Most of the prices, not necessarily, but most of the time, the price increase because of inflation, so that it has an upward trend. Okay, so when you produce scatter plot between the two series, you can see that when one series increase, another one series also the values also increase. So you tend to see that there is positive relationship between the two series, but basically there is not. Although I mean the actual one, there is no actual relationship between two series, but you what we call the scatter plot shows just like there is positive relationship because of the trend, So that why we call it spurious relationship. So you need to be careful for spurious relationship when you produce scatter plot for the two times data. Okay, whether it really represents the relationship between the two series or not. Okay, so you need to keep in your mind that do not directly conclude that there is positive or negative relationship between two times data only based on the scatter plot. So you need to understand also. The possibility. You need to you keep in your mind that the possibility for the spurious relationship concluded based on the scatter plot.